Hi, I'm Gareth Spence and welcome to Tech Talk. In today's show, we're talking about Open RAN, or O-RAN for short. Barely a week goes by without O-RAN making the headlines. In the UK, Adtran and Parallel Wireless have been involved in two government-funded projects that are starting to drive O-RAN results. To help me learn more, I'm joined by Nicolas Scheidecker from Parallel Wireless and Anthony Magee from Adtran. Nicolas, I'd like to start by talking about Project Proteus. What did Parallel Wireless develop in this research group?
So in the Proteus project, we developed a 5G physical layer. The physical layer is a part of the 5G base station where we process the wireless signals, and it's also the most computationally intensive, the hardest on the CPU, and so we developed this physical layer in a new way, which enables us to target multiple types of CPUs from Intel, AMD and ARM.
From what I understand, the software that you developed in this project space is the first of its kind. Is that true?
Yes, so there's a lot of innovation in the CPU, general purpose CPU landscape. Intel, AMD and ARM constantly bring to market new products which have better performance, which have better energy efficiency. And the purpose of the Proteus project was to unlock the potential of Open RAN by developing this physical layer, which is normally tightly coupled to a specific architecture of CPU, and enabling it to be agile and deployable on any of these new architectures. And in doing so, we are bringing to enabling our telco customers the ability to utilize that whole spectrum into their networks.
So what are the implications there for the industry?
So the industry is striving to deliver networks which can handle more data for less energy. And this is exactly what this project is enabling, it's opening this opportunity of utilizing the innovation from the CPU vendors into Open RAN products.
And is this software now being used in real-world scenarios?
So very much so. So that software is now part of our, of our main product, our mainline product. So it's already deployed in the field on certain platforms, and through the DU-Volution program and project and our collaboration with Adtran and the other DU-Volution partners, we are now accelerating the bring up of other platform types, of more use cases, and we are working with Adtran to also work on different deployment topologies.
Anthony, I'd like to bring you into the discussion here. How does Adtran's work in the 5G DU-Volution project complement what Parallel Wireless is doing?
So DU-Volution, as a project sponsored by DCIT, is a project that's looking at supply chain diversification for Open RAN and also looking at neutral host products. How does a neutral host, how is it deployed using shared infrastructure at the transport domain, but allowing tenants to place O-RAN software, DU technology on different compute blades, and the operators may demand their own choice of CPU. So for example, AMD, Intel x86, ARM platforms, we need to be able to offer complete flexibility to those tenants. And it's not Adtran's choice as to which the tenant is going to pick. So the neutral host in this DU-Volution project will have the ability to deploy different CPU types. And for that reason, it's hugely complementary to the direction that Parallel Wireless have taken with their software.
And what's the target use case for this capability?
So the target use case ranges from private 5G, in-building neutral host, campuses and the like, but also we shouldn't underestimate the ability for this to move into the wider small cell market and ultimately the macro cell market as well.
And what are the next steps?
The next steps for us are continue to develop the collaboration that we've built within the project, move to prototype, proof of concept demonstrations for customers. We'll be doing that towards the end of the year and into early next year, and building up hopefully a good customer following from that point onwards.
Gentlemen, thanks for joining me today.